Good morning, my Algebra 1 students. I hope you guys had a fantastic day yesterday. I hope you guys did a phenomenal job on your test over Chapter 6. I hope that you guys are ready to learn and start something new. So we're going to start Chapter 7, which will be over exponents and exponential functions. So today we're going to do our very first lesson, which is zero and negative exponents. So in this lesson, you're going to need to have some paper, a pencil, a calculator, and if you don't have one, you can always go to calculator.net. When you go here, there'll be a scientific calculator that will show, and then there'll also be a list of several different calculators from which you can choose from, ones that do like fractions and things like that. So check out this website if you need a calculator. You need to have a textbook. If you go to page 418, that's where we're going to start our lesson at today. Your homework tonight, which is homework 58, will be straight from your textbook. It will be pages 421 to 422. You'll be doing the evens, 10 through 46. So how I would like for you to do this is once you've completed your homework, I would like for you to take a picture and then upload it to the homework drop in RenWeb. This way I can kind of see your work and give you feedback. If you have access or the ability to use Microsoft Word on your computer, you can always type your answers in Microsoft Word, and then you can upload that as a document, and then I can test that as well. So make sure you send me this way so I can give a better accurate of what you're doing in the class. If you have problems with this, please do not just not do anything and not submit anything. Please be sure to reach out to me through the Remind app, and I will walk you through it or give you some other options on how we can get your homework to me in the most effective way. Alright, so we're going to go ahead and we're going to get started with today's lesson. Alright, so for today we're going to start off just talking about some exponents, and then we're going to talk about a few rules about some exponents. So we're just going to first start out with exponents. And so we're going to talk about a particular exponent in general. So we're going to make a star, say star, star, star. Here we go, star, star, star. There's our beautiful star. We're going to say any number then we're going to say in parentheses, except 0. So any number except for 0 or variable raised to the power of 0 will, I'm going to make it all caps, always, make this in all caps, and underline a couple times, will always equal 1. So we take any number except for 0 or any variable and we raise it to the power of 0, we will always equal 1. So we're going to go ahead and give you an example. So we're going to take this 4, I'm going to raise it to the 0 power. Alright? Okay, so let's bring up the calculator. I'm going to put my little calculator in view in case you don't have one so you can see what we're talking about. We're going to take our 4, we're going to raise it to the 0 power. First we turn our calculator on, so 4, and raise it to the 0 power. Notice what we get. That's right, we get a 1. So 4 raised to the 0 power is equal to 1. Even if it's a big number. So let's do a big number, 315,274. I'm going to raise that to the 0 power. So bring our calculator back in view. Go. We're going to do that 315,274, and we're going to raise it to the 0 power. And looky there, we get a 1. So it doesn't matter how big or small our number is, as long as it's not 0, it will be equal to 1. Now, while you can use a calculator to solve these two problems and get the correct answer, but when we start dealing with variables, you're not going to have a calculator to put a variable in and raise it to that. So you still need to understand the rule that anything raised to the 0 power is equal to 1 with the exception of 0. So I'm going to go ahead and show you this with a variable. Let's have a variable a. If I take a and I raise a to the 0 power, it will also equal 1. And if I take, let's say, a group, let's say 3ab to the 4th, if I take this entire unit, this whole thing, and I raise it to the 0 power, I'll still get 1. Okay, so now remember I told you up here, it says that you guys can use any number except for 0. So now we're going to talk about that 0 guy. All right, so let's go ahead and give that a try real quick. All right, so we're going to take out 0. We're going to raise it to the 0 power. So remember I told you it works for everything except for the 0. So I'm going to go ahead and put this guy back on our screen. We're going to take ours, make it 0, and we're going to raise it to the 0 power. And look what we get. We get a math error. So what this is telling me is that I can't take a 0 and raise it to the 0 power, because what it's trying to do is treat it like taking 0 and dividing it by 0, which doesn't work. So you cannot divide by 0. So this would be an undefined value. So undefined value. All right, so therefore, we can use any number we want, any variable or grouping of numbers and variables, and raise them all to the 0 power, and we get 1. All right, so now we're going to move to our next part of our lesson, which is kind of hanging in here. I'm going to bring this up a little bit so you guys can see. And it's going to be negative exponents. All right, so with our negative exponents, what we're looking here is if we take a negative exponent, which we cannot have. So in this chapter, anytime we see a negative exponent, we've got to change it to a positive exponent. And I'm going to teach you the rule and the procedure to do so. So I'm going to just say a is going to represent any value, whether it's a variable or a number. And I'm going to raise it to a negative n. So n is going to stand for any number that I raise it to. So here we go. We're going to take this a to the negative n right now. In order to change it to have a positive exponent, you take the base, which is a, and you make it a reciprocal of a, which would be 1 over a. And once we write it as a reciprocal, we now change the exponent from a negative to a positive. All right, so now we're going to show that with a number. So we're going to take this number 9, and we'll raise it to the negative 2 power. All right, so our base is 9, and I'm going to rewrite it 1 over 9 as a reciprocal and change the exponent to a positive 2. So now we can solve 9 squared because we know what 9 times 9 is. So 9 times 9 is 81. So 9 to the negative 2 is the same as 1 over 81. So again, I'm going to go ahead and put this up in our calculator here. We're going to put this in. We're going to do 9 to the negative 2, and you'll see we'll get 1 over 81. Or if we wrote it this way, 1 over 9 squared, we'd also get 1 over 81. I know what you're thinking. You're like, well, Miss Hebert, if I can just put this in my calculator and get 1 over 81, what does it matter? Well, there'll be times that we have variables. And variables, remember, you cannot put variables in your calculator. So we have to know the rule. So let's go ahead and look at a rule with a variable. All right, so we're going to take and do a b and raise it to the negative 4 power. We can't put b to the negative 4 in our calculator. So we have to know the rule. So we take the base that the exponent is attached to and write it as a reciprocal, so 1 over b. And then we change our exponent from negative to positive. So that becomes 1 over b to the 4th power. All right, so now we're going to look on page 419 in your book. The got it number 1, which is under the red title that says Problem 1, Simplifying Powers. There is an A through E, so there's 5 choices there. So we're going to go ahead, I'm going to write those 5 choices that we're going to be working with. We got A, which is 4 to the negative 3. We got B, which is in parentheses -5 raised to the 0 power. We have C, which is 3 raised to the -2 power. We have D, which is 6 raised to the -1 power. And we have E, which is in parentheses -4 raised to the -2 power. So these are the got it ones, and they're on the page 419, about halfway down the page in that first setting underneath the problem 1. All right, so what we're going to do is simplify these. So what they want us to do is write them first without negative exponents, and then they're going to have us simplify that value, kind of like we did here. We're going to take it and first write it with a positive exponent, and then simplify our answer. So we're going to follow this pattern right here for these guys and use any of our rules up above about anything being raised to the 0 power with the exception of 0. All right, so we're going to start off with this one. Since we have a negative exponent, we're going to rewrite this by taking our 4 and doing the reciprocal, which is 1/4. And then we're going to change it from a negative exponent to a positive exponent of 3. Then we'll simplify. So now we're going to do 4 to the 3rd power. So 4 to the 3rd power is 64, because 4 times 4 times 4 is 64. This would be our final answer. Now letter B, we have -5, this whole thing being raised to the 0 power. So just like above, if we have something in parentheses being raised to the 0 power, whatever is in here will now be equal to 1. So that means this whole unit right here is just equal to 1. All right, so now let's try doing these. All right, so we're going to go here. All right, so Angel, what would we do here? What's the first step we would do? That's correct. I'm going to take that 3 and rewrite it as 1/3. And then what will my new exponent be? You're right, it would be a positive 2. So now I simplify. So Angel, what is 3 squared? You're correct, it's 9, because 3 times 3 is 9. All right, so Ethan, how would I handle this one? What's the first step here? That's correct, Ethan. I'll take that 6 and rewrite it as 1/6. And what will be the new exponent? Correct, it'll be a positive 1. Well, what is 6 to the 1st power the same as? That's right, Ethan, it's 6. So 1/6 would be my final answer. Now let's look at this last one. This whole thing is in parentheses being raised to the -2. So when I bring it down, I want to keep it that way. My whole thing in parentheses. I'm going to keep it that way. Then I want to raise it now to a positive 2. I'm going to show you in a minute what the difference would be if I did not write it this way. All right, so now I got 1/, and then this is -4 squared, which means -4 times -4. So a negative times a negative is a positive, and 4 times 4 is 16. So let's bring this guy back up into the screen here. So we're going to look at this guy here. If you did not put your parentheses in here, and you just try to do -4, and we're going to try to raise it to the -2. Oops, the -2. We're going to get -1/16, and we did not get a -1/16. But if I put in parentheses -4 and I raise it to the -2, I'm going to get the correct answer. The reason what's happening is when it comes down to this stage right here where you have this -4 being squared, if we have written like this, this literally means right here for us to take -4 and multiply it by -4. And that produces a positive 16. That's what's happening. But if you leave off those parentheses and you just type in -4 squared like this, you get a -16, because what's happening when you do -4 squared like this is saying negative times 4 times 4. That's what this means. Which now I get a negative times 16, which is -16. So these two values mean completely different things. This and this are two different values. So it's very important that if you have a negative and you're squaring the whole entire thing, you leave it in parentheses to indicate that, because you're multiplying a negative times a negative to get a positive. All right, so I'm going to go ahead and leave that alone for a second. And we're going to go ahead and try a few in your book. So turn to page 421. This is kind of where you're going to see your homework. So since you guys are doing the evens tonight, I'm going to do some odds with you for practice. Okay, so we're going to go to page 421. And I'm going to show you exactly what I'm going to ask of you on the homework, so you will not be confused, because how we work out these odds is exactly how I want you to work out the evens. So it's real important that you're paying attention through this portion and making notes, because I'm giving you specifics of how I want them to look. All right? So here we go. We're going to do the odds. So we're going to start with number 9. All right, we got 3 to the negative 2, which we just did this a second ago in the warm-up. Right? So how do we write this, Lakeisha? Fantastic. I'm going to write it as 1 over 3 squared. That's the first step. Then from here, now I'm going to go ahead and simplify that. I'm going to solve 3 to the second power. So I'll put that in my calculator and do 3 times 3, which is what, Lakeisha? That's correct. It's 9. So now my final answer would be 1 over 9. But I showed my work along the way. And for you to get credit for homework tonight, you must show me the problem, show me the work, and the final answer. So that's very important that you do all those steps. Okay, here we go. All right. We're going to try the next one. We're number 11. So number 11. All right, we got in parentheses, negative 5, and it's being squared. All right, so Miss Amaya, how are we going to first write this? Beautiful, beautiful. She said we're going to put 1 over, and she said to keep it the negative 5 in parentheses and raise it to the second power. That is beautiful, because our negative 5 is already in parentheses, so we want to keep it in parentheses. All right, so here we go. So then what would our final answer be, Amaya? What is negative 5 squared? Fantastic. It is 25. Let me go ahead and box that in. That would be my final answer. And again, I showed my work along the way. All right. So we're going to go ahead. We're going to move down, and we're going to do number 15 now. Now let's look at number 15. We've got negative 3 and raised to the 0 power. All right, let's talk about this one. So the difference between this negative 5, oh, that should be a negative 2 power up there, guys, sorry. This negative 5 being raised to a negative 2 power, and this negative 3 being raised to the 0 power. This literally means negative and then our 3 being raised to the 0 power. That's what this is asking of you. All right? So what is happening here? There's like a negative 1. Right here we don't see. So this is like negative 1 times 3 to the 0 power. Which means now we've got negative 1 times whatever 3 to the 0 power happens to be. And so what is any number raised to the 0 power equal to, Cheyenne? That is correct. It's equal to 1. So now we've got negative 1 times positive 1, which is a negative 1. And that is our final answer. The reason why this answer is not positive 1 is because now the 0 is not attached to this negative. If it was, this whole thing would be in parentheses. The 0 is only attached to the 3, so just this portion turns to a positive 1, and then times the negative out front makes it a negative 1. All right, so we're going to do number 17, which is 1 over 2 to the 0 power. All right, do we have any negative exponents right now? You're 100% correct. We do not. All right, so now Isaiah, what would be 2 to the 0 power equal to? Beautiful. He said it's equal to 1. So 1 over 1. Then I can divide. What is 1 divided by 1, Isaiah? Correct. That is 1. So then my final answer would be a positive 1. All right. And now we're going to go ahead and do the last one on that section, number 19. All right. So we're going to do 1.5 to the negative 2. All right. So Who thinks they could solve this one? All right, Miss Tanaya, tell me how I can do this. What will I write first? Beautiful. She says I'm going to put 1 over 1.5 and raise it to the second power. Gorgeous, gorgeous, gorgeous. All right, so now what do I do from here? Anyone know? Okay, all right, all right. Angel said she's going to do 1.5 squared. So let's do that. Let's do 1.5 squared. So Angel, what's 1.5 times 1.5? All right. She said she gets 2.25, which is right. Okay, so we don't want to leave a decimal in our calculators. So what we're going to do, we'll bring our calculator to view in here. We're going to take this and put this in our calculator. We're going to do 1 divided by 2.25, and I'm going to get 4/9. Now, if you're on a non-calculator that does this, you're going to have to change your decimal value, which you would get 0.444444444. We're going to change that back. As you can see, that's repeating. We're going to have to change it to a fraction here. Or when you got to this stage here, when you had the 1 over 1.5 squared, and that's another one. You could also change your 1.5 squared. You get 9 over 4 here. You could make this 2.25 into a fraction. If we did, this would be the same as 1 over 9 over 4. And you got to use your knowledge of what you know about fractions. Is that we keep the numerator. We change the division bar that we have here. Remember, division is going to change to multiplication. The fraction on the right is going to do a flip. So then we have 1 times 4/9, which is 4/9. So our final answer would be 4/9. So just in case you don't have a calculator that does all the beautiful fractions, you can always do this, or that calculator.net does have some fraction conversions in there so that you can use that ability. All right. Or if you have a possible way to get one of these guys off of Walmart, it'd be great to have one. You'll use it for the rest of your math career. It'll be an investment to put in there if you can afford to get one right now. If you can't, I totally understand. I'm not saying that. I'm just saying if you can, that's great. If not, we totally understand. All right, so now we're going to go ahead and move back to page 419 in your textbook. And I'm going to move this page up because I don't want to lose all of our paper down here. And we're going to do the second part, which is simplifying exponential expressions. So example 2. Which is going to be simplifying exponential expressions. All right, so here we go. All right, so in order to simplify our exponential expressions, we have to look at things that either have positive or negative exponents. And when they have positive exponents, we don't want to mess with them. We want to leave them like locked in place. We don't want to move them around. We only want to move the things that have negative exponents. So we're going to start out with something kind of simple and then explain this to you. So we get 5a to the third power, and then a b to the negative 2 power. So up here we have 3 individual terms. We got a 5 who is raised to an understood 1 power. We have an a raised to the third power, and we have a b raised to the negative 2 power. All right, so what we're going to do here, all right guys, you might see kind of a little bit of a holdback because there was a little glitch in the recording, so hopefully we'll just kind of go back to here. I don't know how far back it went, so we're going to go ahead and start with this again. So apologize for that. There must have been a connection issue, so it's all right. We're going to be all right. We can work through this. Okay, so what we're going to do is start right here with this problem, simplifying exponential expression. This is example 2, so just in case, I know there was a glitch in the recording, so I do apologize for that. All right, so here we go. So we're going to look at our exponential expression, and we're going to break it apart. So first of all, we're going to take this whole entire expression, we're going to put it over 1. We can take any value, number or variable, and we can put it over 1, and we've not changed the value. Because if I take 5a cubed, b to the negative 2, and divide it by 1, I stay with 5a cubed b to the negative 2. So I didn't change the value by putting it over a 1. So the reason why I did this is to show you that anytime we deal with a mixture of positive exponents and negative exponents, we are not going to move the positive exponents from their location. So wherever they are located, we are going to leave them right there. We will only move any value up here that contains a negative exponent. So let's go look at our top. So on the top of our fraction, we have a 5 that has a positive exponent of 1. It's understood, even though you don't see a 1, this 5 is raised to the first power. Then we have our a, which is raised to the third power. So that's a positive 3, so we're going to leave it just like that. Our b, however, is raised to the negative 2 power. And we learned earlier that if we have b raised to the negative 2 power, that we can rewrite this as 1 over b to the second power. So notice now my b to the negative 2 is written in the denominator with a positive exponent. So my b to the negative 2 must move to the denominator to get a positive exponent of 2. Now you're like, well, what about that 1 up there? Well, this 1, if I'm to put it up here, would be 1 times 5, which is 5. So if there's any number left or any individual variable left, you don't need to worry about the 1 because it's automatically understood when you multiply it by what value is already there. So this would be our final answer. Okay, so now what we're going to do is we're going to look at the bottom of page 419, and there are A through E. And we're going to look at those A through E's, and I'm going to show you how to work similar ones that you're going to have, because they're not all going to be cookie cutter and they're all not going to look the same. So to make sure that you guys are understanding how this will roll. All right, so part A, we've got x to the negative 9. B is 1 over n to the negative 8. C is 4 times c to the negative 3 times b. D is 2 over a to the negative 3. So again, I'm on page 419 in your textbooks. And E is n to the negative 5 over m to the second. All right, so I'll give you a moment to write these down, or just go ahead and pause the video and write down your 5 things, and then when you're ready to start working with them, go ahead and resume the video. That's the beauty of this recorded lesson. You can pause it and rewind it and get all the good juju you need out of it. All right, so part A is going to be very simple. It's going to be very similar to the one right here directly above it. So we only have just a variable. So we're going to rewrite this to 1 over our x, and we're going to raise it to a positive 9 power. This would be our final answer. We can't do anything else with that. Beautiful, final answer. Now on our second one, we notice that our negative exponent is in the denominator. So to make it positive, I have to move it to the numerator and multiply that value times 1. Well, 1 times anything is that value. So if I move that n to the numerator and give it a positive exponent of 8 and multiply it by 1, I get 1n to the 8. So this would be my final answer. Gorgeous. Now as we look at letter C, we notice we got a combination looking very similar to the example we did here. We've got a coefficient and a variable that have positive exponents and another variable with a negative exponent. So the ones that have positive exponents, 4 and b, will stay 4 and b, right where they are. They do not move. Our c, however, has a negative exponent, so I have to move it to the denominator to make it a positive exponent of 3. So this would be your final answer. Okay? All right, so now we're going to move to part D. Part D is another type you might see. So our 2 is in the numerator, and it has a positive exponent, so it's going to stay right there in the numerator. I'm not going to mess with it. But we notice that my a to the negative 3 is in the denominator, so I have to move it up to the top to get a positive exponent and multiply it by 2. So 2 times a would be 2a, and now it's a positive exponent of 3. So I'm going to go ahead and box that in. That's my final answer. All right, so now we're going to move to letter E. In letter E, we notice here that our only positive exponent is located in the denominator. So we are going to leave it in the denominator. So m to the second. We're not going to mess with that m to the second. It's going to stay right there in that denominator. All right, so now our n to the negative 5 is in the numerator. So to make it positive, it has to move down to the denominator. So that n has to move down here to become a positive 5. Now you're like, well, there ain't nothing left on the top. Well, there is, because remember, there's a coefficient of 1 here that we don't see. So that 1 stays right where it's at, 1. So then my final answer is 1 over m squared n to the 5th. All right, so now we're going to move to page 421 in your books. So put this page number, page 421. And we're going to look at the second part of what I'm wanting you to do. Again, you guys are going to be doing the evens for homework. So we're going to work some of the odds together and make sure you understand what's going on in these problems. All right, so we're going to start easy peasy. We're going to do number 21 to start with. And it is 4 times a times b to the 0 power. All right, so let's take a look at this one first. And again, I'm showing you how I want you to write these problems out so that way you do not get them wrong. And this is how you'll have to do the work to get the credit. All right, we have this b, and it is raised to the 0 power. The 0 is not attached to the a. The 0 is not attached to the 4. If it was, it'd be in parentheses, and we do not have parentheses. So the only variable that has the 0 exponent is just the b. So we learned that anything raised to the 0 power is equal to what, Cheyenne? That's right, 1. So this is the same as 4 times a times 1. That's literally what that means. So 4 times the a times the b to the 0, which is 1. Now we can simplify by multiplying the coefficients. 4 times 1, which is 4, and then times a. 4a. Final answer. All right. We're going to move and do number 23. All right, number 23 says 5 times x to the negative 4. All right, so like our previous problems up here, we only are going to move whatever has a negative exponent. So this negative 4 is only attached to the x. It is not attached to the 5. If it was, there'd be parentheses around the entire 5x to say it goes to both things. So it's only going to the x. So that means we're going to go ahead and keep the 5 in the numerator right where it belongs. But this x, because it has a negative 4, must move to the denominator to become a positive 4. And then we're going to box this in, and this will be our final answer. All right, so we're going to move and do number 25. All right, number 25, move this up. Says 3 to the negative 2 all over n. All right, so we're going to go ahead and work this guy out. Okay, so remember, anything that has a positive exponent, we want to leave it exactly where it is. So I'm going to leave that n right here. I'm not going to mess with that n. But this 3 has a negative exponent. So I've got to move it to the denominator. So now I'm going to put this, my line a little bit longer. So times 3 to the 2nd power. All right. So now on the top, remember there's an understood 1 up here. So now we're going to solve this. So we got 1 over n times, and 3 squared is 9. We're not going to write n9. So what's n times 9? Because remember, we write these, we always do coefficient first, followed by the variable second. So now we got 9n. So this would be our final answer. Okay, so now we're going to move on, and we're going to try number 27. Right? 27 has 3 times x to the negative 2 over y. So in here, you should notice how many things in here, move this up, Isaiah, have a negative exponent. So of what we see, how many things have a negative exponent? That's right. We only have one thing with a negative exponent. So Isaiah, what is that one thing? Correct. It's the x. The x has a negative exponent of negative 2. So what we're going to do is keep our 3, which has a positive exponent, right where it's at. We're going to keep our y right where it's at. So how can I make that negative exponent become a positive exponent, Ava? Correct. I'm going to bring it to the bottom and give it a positive exponent. Now, when you write your variables, I like you to write them in alphabetical order. So I want you to go ahead and put your 3, and then since we know x comes before and the y in the alphabet, and then we'll do the y second, making this your final answer. Alrighty. Alright, so now we're going to go ahead and try number 29. 29. Alright, 29 says c to the negative 5 and d to the negative 7. Alright, who thinks they could tell me what we would do to this problem? Fantastic, Lakeisha. Tell me what we do. Okay, Lakeisha said we have 2 variables that each have a negative exponent, so they can't stay there. They have to go to the bottom. Beautiful. Okay, so she's going to say these got to go to the bottom. If they go to the bottom, Lakeisha, what do they become? Correct. They become c to the positive 5, d to the positive 7. All right, so do I leave it like that, Angel? No, you're right. I don't. So what stays up here, Angel? Correct. That's a 1. So 1 stays there because remember our coefficient of understood 1's here we just don't see. So then there's our final answer. And if we divide anything by 1, we get 1. All right, so here we go. We're going to move on. We're going to go ahead and try number 33. All right, so 33 picks up the pace just a little bit, but I want to make sure that you see something similar to this as we work. We'll do 33 and 35 and then move to the next part of our lesson. All right, so we've got 6 times a to the negative 1, c to the negative 3, all over d to the 0 power. All right, so let's look at this guy. He's going to be kind of interesting. All right, so here we've got some negative exponents and some 0 exponents. So let's look at these guys together and figure this out. All right, so first of all, let's see who is not going to move. That is correct, Amaya. 6 is not going to move. 6 is going to stay right where it's at. All right, well now who is going to move? Fantastic, Miss Cheyenne. The A and the C. So I bring the A down here, and we get the positive exponent of 1. So do I need to put a 1? You're right, Cheyenne, I don't. It's an understood 1. And then my C becomes a positive exponent of 3. Beautiful. But what do I do about this d to the 0 power? What does this guy become right here? What does d to the 0 power equal to? That's right, Angel. It's equal to 1 because anything raised to the 0 power is 1. So if I change it to a 1, I'd have a 1 right here. Do I really need that 1 right there in front? No, because 1 times a times c to the third is 1ac to the third. So then I'm just going to make that a part of my answer and box it in. Final, we are done. All right, I don't think... let's do one where you might have something. I'm going to make something up. Let's do... I'll make one. This is a makeup problem. You like this, Miss Hebert? It's going to give y'all a makeup one. Let's do 5x to the negative 2, y to the 0 power over 3, and let's do p to the negative 4 and r to the 3. All right, so I'm giving you a toughie. Oh, you like this one, don't y'all? I'm stretching your brain, but that's all right. So when you see something like this and everything's all discombobulated, what I want you to first of all look at is find out who has a positive exponent and write your problem and leave them exactly where they are. So the first thing we need to identify in this problem is who has a positive exponent. All right, so positive exponents are the 5 and the 3, and of course you have this 0 over here, y to the 0. So we're going to talk about that guy. So let's take this y to the 0 and let's talk about him. So y to the 0 is equal to what value, Ethan? That's correct, 1. All right, so now if I take this 1 and I multiply it by this 5, what do I get? That's right, Amaya, I get 5. So 5 times the 1 still stays 5, and it's a positive exponent, so my 5 stays right where it's at. My 3 has a positive exponent, so it's going to stay exactly where it's at. Do not mess with those right now. All right, so now my x has a negative exponent, so he needs to move to the bottom to get a positive exponent. My p has a negative exponent, so it needs to move to the top to get a positive exponent. My r has a positive exponent, so it's going to stay right down here on the bottom. Now, once we get to here, again, I told you I like to put the letters in alphabetical order. It makes it easier to read and to grade. The second thing is we look at our coefficients and see, can we reduce them? Can you reduce 5/3? You cannot. There's no value that divides into 5 that also divides into 3 other than 1. So now all we're left to do is rewrite our problem with our variables in alphabetical order. Since r becomes before x in the alphabet, we'll do the r to the 3rd, then our x to the 2nd, final answer. There we go. All right, so now we're going to go ahead and we're going to turn back just over to the page to the left of you, evaluating an exponential. So we're going to example 3, which is the page right beside you, page 420. So we're going to go to example 3. Let's move this around a little bit. Apologize for all that crazy there. So we're going to go to example 3. And we're going to do evaluating an exponential expression. Now, you've already done evaluating this year, a lot. So evaluating is where we take a variable and we substitute it for a number, and then we solve. So our first example is going to have, starting us out with 3 times s to the 3rd power times t to the -2 power. And then they're going to tell you what they want you to replace s with and what they want you to replace t with. All right, so now they're going to tell us they want us to take out s. Everywhere we see an s, they want us to replace this with a +2. And everywhere we see a little t, we're going to replace it with a -3. All right, so before we start evaluating, we want to make sure we rewrite this and get rid of all of the negative exponents first. So let's go ahead and get rid of all the negative exponents, and that makes life so much easier. All right, so right now we have the 3 has a positive exponent, and the s has a positive exponent. So we're going to keep this. I'm going to transform this and keep the 3 and the s to the 3rd in the right location because they have positive exponents. But my t has a negative exponent, so it needs to move to the bottom to get a positive exponent. So from here, now I'll do my substitution. So come over, I got my 3 times my s value being raised to the 3rd power, all over my t value being raised to the 2nd power. So now I'm going to drop those values in. So I'm going to take the s value and replace it with a 2, and the t value and replace it with a -3. So again, it's important that we put parentheses where we drop things in so that we do not mess up on multiplying or squaring positive and negative numbers. We want to have the correct answers. All right, so now we got this 3 times whatever 2 to the 3rd is. So this literally means 2 times 2 times 2. So, sorry. 2 times 2 is 4. 4 times 2 is 8. And on the bottom, this means, literally, -3 times -3. So -3 times -3 is +9. We're going to go over here and we're going to simplify. 3 times 8 is 24 over 9. Then we have to ask ourselves, can we reduce this fraction? And we can. because 24 is divisible by 3 and 9 is divisible by 3. So we're going to go ahead and divide both of those numbers by 3. So 24 divided by 3 is 8 and 9 divided by 3 is 3. Now we cannot reduce this any lower, so then my final answer becomes 8 over 3. All right, so we're going to try your Got It 3. There are 4 problems, A, B, C, and D, and then we're going to use the same values for them. So move this up a smidge, keep this guy in view real quick. All right, so our A value that we're going to deal with is n to the negative 4 and w to the 0. Our B1 is n to the negative 1 over w to the second. Our C value is n to the 0 over w to the 6th power. And our D1 is 1 over n times w to the negative 1. All right, so for all 4 of these, we're going to use the same substitution values. We're going to let n be equal to negative 2 and w be equal to 5. So for solving all 4 of these, this is what we're going to do. So again, before I want you to start substituting in, I want you to rewrite each one containing no negative exponents. So first of all, with this one, I'm going to keep this n to the negative 4 for now. But this w, let's squeeze them up here like this. This w to the 0 power is equal to what value, Mia? That's right, it's equal to 1. So now I've got 1 times n to the negative 4, which is n to the negative 4. So therefore, that's the next step. As I transition down, I don't need a negative exponent. So that means he has to move to the denominator to become n to the positive 4 and put a 1 over him. All right, so we've changed A. A looks beautiful and gorgeous. All right, so we're going to move to the next one. We'll do the substitution in a minute later. All right, so we're going to go to this guy. Bring him down. All right, so we got an w to the 2nd power as a positive exponent. So we're going to leave that w to the 2nd power right where it's at. We don't want to move him. Looks like a wonky donkey w. Oh, there. Okay. This n has a negative 1 exponent, so I need to move him to the denominator and give him a positive exponent, which is an understood 1. Then I leave a 1 on the numerator because there's an understood 1 up here that we don't see. All right, so we're going to move this guy. So again, we've got this n to the 0 power, which is equal to what, Ethan? That's right, 1. So now I got 1, and my w has a positive exponent of 6, so it's going to stay just like that. All right, so then we're going to move to the D1. My 1 stays where it's at because it's a positive exponent of 1. My n stays where it's at, but my w has a negative exponent, so it must move to the top and become a positive exponent of w. So this is like 1w over n. So from here, we can now start doing our substitution process. All right, so let's go ahead and start that. So we got 1 over our n value to the 4th power. So let's go ahead and we'll substitute in there what n is. N is equal to negative 2. So we're going to put that negative 2 in that spot. So now we've got this value, which means negative 2 times negative 2 times negative 2 times negative 2. So it literally means negative 2 times negative 2 times negative 2 times negative 2. That's literally what that negative 2 to the 4th power is. So we're going to solve that. Bring this up a little bit. So now we got 1 over. So we can put in our calculators up here. Bring this in. We can put in a negative 2 and raise it to the 4th power, and you'll get 16. So we got 1 over 16. Final answer. All right, so we're going to move to this one. So now we got 1 over whatever our n value is times our W value squared. So we're going to go ahead and substitute our values. N is -2, and W is 5. All right, so what this means literally is 1 over -2 times 5 times 5. That's what that's asking of us. So we do this, we got 5 times 5, which we know is 25. 25 times -2 is -50. So this would be our final answer, 1 over -50. All right, so we're going to go ahead and move to the next one. I'm going to bring this down. We've got 1 over, we're going to take our W value and raise it to the 6th power. So our W power is equal to 5. So what this literally means is 1 over 5 times 5 times 5 times 5 times 5 times 5. So we'll squeeze all 6 in. 1, 2, 3, 4, 5, 6. Or we can put in our calculators 5 and raise it to the 6th power, and we get 15,625. So this becomes 1 over 15,625. Then we'll do the last one. So we've got W over N. And we're going to put in our values. W is equal to 5. N is equal to -2. So we'll go to our problem here. We can't do anything with 5. It just stays 5. We can't do anything with -2. It just stays -2. And 5 is not divisible by -2. And it can't reduce, so we just leave it. 5 over -2. We do not change it to a decimal. Just leave it as a fraction. All right, so now we're going to turn in your books to page 422. 422. So we're going to bring this back down. We're going to show you some problems to do together. That's when you're doing the homework, what I'm expecting of you, and what I want the homework to look like. So page 422. All right, page 422. They're going to tell us in this section we want to use R will be equal to -3, and S will be equal to 5. So we're only going to do 2 problems in here. I'm going to do number 39 and 43. So I'm going to do 39 and then 43. So 39 is 3R over S to the -2. And 43 is R to the -4 times S to the 2nd. So those are the only 2 that we're going to do right now. All right, so step 1, what do we do first, Laquan? He said we rewrite with positive exponents. That is correct. That's the first thing we do. We're going to rewrite with positive exponents. All right, so Tanaya, who up here already has positive exponents? Fantastic. The 3 and the R. So that means the 3 and the R are going to stay right where they are, 3 and R. But what about this S? This S has a negative exponent. So, Fabian, what do I do with this S to the -2? Fantastic. I bring it up, so now comes S to the +2. Gorgeous, gorgeous job. All right. So as we move over here, Amaya, what do we do first here? Correct. She said we do what Laquan said a minute ago. We go ahead and rewrite this with positive exponents. So Amaya, with that in mind, who is going to stay right where they are? Fantastic. The S to the 2nd power is going to stay right where it's at. So Mia, what happens to this R to the -4? Correct. It's going to go on the bottom. It's going to go down to the denominator to become a +4. So now that we've rewritten them with positive exponents, now what do we do, Lakeisha? Fantastic. We're going to substitute in. So now I've got 3 times whatever the R value is, times whatever the S value is, squared. So again, we always want to put parentheses where we're showing substitution. This helps us to not make mistakes, especially if our numbers are negative. All right, so I'm going to go ahead and drop those values in. What do we say R is equal to, Angel? Correct, -3. And Angel, what is S equal to? Beautiful, 5. So way back when we learned about PEMDAS, please excuse my dear Aunt Sally, we have to solve the exponents first. So I need to solve this 5 to the second power first. So I've got 3 times negative 3. And what is 5 to the second power, Isaiah? Beautiful, 25. All right. So now we're going to move solving this part. So Ava, what is 3 times negative 3? Beautiful. She said it's negative 9. So I got negative 9 times 25. So then I'm going to do negative 9 times 25. So Ethan, what do we get? Fantastic. We get negative 225. So this would be your final answer. And this is how I want you guys to set them up. You're going to write your problem, rewrite it with positive exponents, show me your substitution, and then show me your work on how you got down to here. I need to see your work, otherwise I cannot give you the full credit for this. All right, so we're going to move to the next part. So we're going to do substitution. So now, I'm going to move over here to the side. I got the value of whatever s is squared over whatever the r value is to the 4th power. So, Cheyenne, what is the s value equal to? That is correct, negative 3. And what is the r value equal to? The s value, no, s value is not negative 3. That is 5. The r value is negative 3. I misunderstood you, Cheyenne. I know you said it right, and I wrote it wrong. I'm so sorry, darling. Please forgive me. All right, so now we're going to solve these exponents. We're going to do 5 to the second power. So 5 times 5 is what? Ethan. That's correct. It is 25. All right, so now we're going to find this negative 3, and we're going to raise it to the 4th power. Remember that same thing as negative 3 times a negative 3 times a negative 3 times another negative 3. And we do that, what do we get? That's right, Isaiah. We get 81. Beautiful. Fantastical job. I am so proud of you guys. All right, so now looking at what we have here, this 25 over 81 cannot reduce any lower because 25 is only have factors of 1, 5, and 25. And 5 is not going into 81, and 25 is not going to 81. So this would be our final answer. All right, so now we're going to move to the last part, which is pretty easy. It's just using what we've done here, but now there'll be a story problem involved with it. Okay, so let's turn your books back to page 420, and we're going to go and do example 4. So example 4, which is problem 4 in your book, I think it says. Okay, and this is using an exponential expression. Okay, so as we're looking at this problem 4 or example 4, I want you to follow along in your textbook because I don't have that ability to bring this up here under the dot camera that I'm videoing for you guys. So you need to be on page 420 if you want to follow along. So if you don't have your textbook, go ahead and pause your video, go grab your textbook, open to page 420, come back and turn your video on so you can follow with us. Okay, so example 4 is about population growth. And it says a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression. So I'm going to write that expression down. 1,000 times 2 to the h, where h is equal to the number of hours after a scientist measures the population size. So I'm going to write that down. H equals the number of hours after a scientist measures the population size. All right. So now here is our exponential equation. And here is our value, or what h up here is standing for. Then it says evaluate. That's what you were just doing up here, evaluating. They want you to evaluate this expression for h equaling 0, and they want you to evaluate it when h is equal to -3. Then they want to know, what does the value of the expression represent in each situation? Bring this back up. So we're saying if h is equal to 0 and if h is equal to -3, what does that number tell us? So we're going to go ahead and solve these problems by doing the evaluation. So we use it with the 0. So we got 1,000 times 2, and we're going to substitute that h with a 0. So 2 to the 0 power. All right, so let's use our knowledge of what we know. So Ava, what is 2 to the 0 power equal to? Correct. So we got 1,000 times 1, because she said the 0 power is equal to 1. So now we're going to multiply 1,000 times 1, and we get 1,000. So in your textbook, it says the value of the expression when we let h be 0, we get 1,000. That means there were 1,000 bacteria at the time that the scientists measured the population. Because 0 means 0 hours has passed by. No time is gone. So this was the starting population of the bacteria. Okay, put that down there. All right, so that means when the starting population of bacteria of the experiment. We'll put that in exponents here because I want to make sure you understand. This is when they first started the experiment. So when he's all of a sudden the scientist said, "Hey, I want to find out some information." Okay, let's go ahead and see what it looks like right now. Even though this bacteria had probably been there long before he started this experiment, but when he decided to start the experiment, this is how many bacteria were already there. All right, so now we're going to do the next one. So we got this 1,000 times 2 to the -3. All right, so now we got to go ahead and rewrite this because we can't have a negative exponent. So, Miss Ava, how do I write 2 to the -3 with a positive exponent? Beautiful. She says I do my 1,000 times 1 over 2 to the 3rd power. Gorgeous. Beautiful job. Fantastic. I love it. All right, so Fabian, let's go ahead and simplify this. What does 1 over 2 to the 3rd become? Beautiful. 1 over 8, because 2 times 2 times 2 is 8. So now we've got to multiply 1,000 times 1/8, and we get what, Miss Mia? All right, you're correct. We get 125. So now, what is that 125? If we look in our book, it's telling us now. It says the value of the expression h equals -3 is 125, which we got. There were 125 bacteria before the scientist took the measurement. So this represents the bacteria 3 hours before he measured. So 3 hours before the scientists ever started to measure or check the size of the population, there were 125. 3 hours later, there were 1,000 bacteria. That's kind of crazy how fast that bacteria is going. So what they're asking us in this section is they're going to give you an expression. They're going to tell you what they want you to replace those values with, the variable with. And then you're going to replace that and say, what does it mean? What does it tell me? All right, so go ahead and turn your books to page 423. We'll do number 45 together, and tonight you'll do number 46. So it's our last problem, and after that you'll go ahead and get started. So problem 45 is our very last problem on page 422. Our last problem of the day. So again, we're going to read through that together. It says internet traffic. It says the number of visitors to a certain website triples every month. The number of visitors is modeled by the expression. So we're going to write that expression down. 8,100 times 3 to the m. All right, that's what it's telling me. Then it says where m is the number of months after the number of visitors was measured. So let's write that down. M is equal to the number of months after the number of visitors Now for homework tonight, you will not have to write this portion down. I'm doing it for your benefit so you understand how I'm understanding what this will represent at the end. Was measured. So this is going to tell us how many months after the number of visitors were measured. So we measured them in, say, June, and we didn't measure to 3 months later. Then that's how many visitors would be 3 months after June. So it says evaluate the expression for m equals -4. So now basically, are we wanting future numbers or prior numbers when we have a negative exponent? Fantastic, Fabian. Because it's negative, we want 4 months before. So now I want to know what the population would be 4 months before they ever measured the number of visitors. Because if we do 0 months, if we did 3 to the 0 power, what's anything raised to the 0 power, Cheyenne? That's correct, 1. And 1 times 8100 would be 8100. So when they first started this, there were 8,100 people. That's how many visitors that they had measured. But I want to know how many visitors were there 4 months before they started this process of determining how many visitors were coming through. All right, so we're going to go ahead and do our little substitution. We got our 8,100 times 3 to the -4. All right, so what do we first got to do, Tanaya? Correct. We got to write this 3 to the -4 with positive exponent. So it becomes 8,100. And how do I write 3 to the -4 as a positive exponent, Tanaya? Beautiful job. 1 over 3 to the 4th power. Gorgeous, gorgeous. So now I've got to solve that 3 to the 4th power. Fabian, what would 3 to the 4th power be? Gorgeous, 81. So I got 8,100 times 1 over 81. So now I'm going to take this 8,100 and multiply it by 1 over 81 so I can find out what value that would be. And what will that equal? Ethan? Fantastic. That will equal 100. That means before this experiment started, 4 months before, there were 100 visitors measured. So they had 100 visitors 4 months before the experiment started. So we're going to write that down. There were 100 visitors. And we want to tell that this was 4 months before. 4 months before visitors were measured. This would be my final answer. Only are you telling me how many visitors there were. You're telling me that this tells me what it represented 4 months before visitors were measured. So you're going to do this for number 46 in your book. All right, so tonight's homework, again, are the evens 10 through 46 on pages 421 and 422. Make sure you write legibly. If you cannot write legibly, then you need to type it somewhere and take a picture or something. So I need to be able to see your work. All right, so have a great weekend, and, well, it ain't weekend yet. Have a great night. And then we'll get back tomorrow with our new lesson. Have a great day.